Welcome to the Presby Environmental Certification Training class. In these presentations, you'll be introduced to the Advanced Enviroseptic Wastewater Treatment System for your state. If you need answers to questions while you're designing or installing the system, and you cannot find the answers in the manual, please feel free to contact us at the 800 number shown on the screen. You could also send an email to info@presby.com and someone will promptly get you an answer. Our website has recently had a makeover and we're working hard to add additional training materials and tutorials. Please follow the link to Presby University on our homepage to find these additional videos. You'll also find your state design and installation manual, test data, and information about some of our other products that may become available in your area in the future. As part of our certification, you are required to download and read the most current version of the design and installation manual for your state. This training is only an overview. It's not possible to cover everything detailed in the manual. It's our intention to provide you with enough understanding to feel comfortable with the basics of design and installation. It is not necessary to read the manual prior to watching these presentations, but it's necessary to pass the assessment test to gain certification. The test is our way of demonstrating to your state and local regulators that you have the necessary knowledge to successfully work with Advanced Enviroseptic. If you are already an industry professional, many of these topics we're about to discuss will be very familiar. Certification training has been divided into 4 categories, starting with an introduction to the product. Then we'll detail the specific system configurations allowed for use with Advanced Enviroseptic. With that understanding, we'll move on to the process of how a system is designed to meet the needs of your specific daily design flow. And finally, we'll cover the specifics of installation and assembly. You'll hear and see AES used as a shorthand for Advanced Enviroseptic, so don't be confused when you hear me use that term or see it in the coming slides. In this section, we're going to discuss some of the most important advantages to using AES. Then introduce the individual components that are typically used in most systems, which includes a discussion about the sand surrounding the pipes, or what we refer to as the system sand. And we'll also include a few words about the familiar distribution box configuration. The AES system offers a variety of benefits. It is a completely passive, non-mechanical advanced treatment system that utilizes both aerobic and anaerobic bacteria to provide superior treatment results. The AES system treats and disperses in the same footprint. Given its advanced treatment capabilities, the system footprint is smaller. With its unique design features, it can be installed easily and in diverse bed configurations. One of the most important reasons to use AES is its superior treatment capabilities, which are illustrated here. A number of years ago, we contracted third-party testing from a firm in Canada, which resulted in AES receiving the nationally recognized NSF 40 Class 1 certification, a certification normally reserved for mechanical treatment units. The beaker on the left represents a leachate sample that was taken 6 to 12 inches below a traditional pipe and stone field. And the beaker on the right represents a sample taken 6 to 12 inches below an enviroseptic pipe. Visually, you get a sense of the treatment quality of the effluent leaving each system. An important point for AES is that nearly all of the effluent treatment happens within the AES pipe. The surrounding sands only serve to carry treated wastewater back to the subsoil and provide a polishing effect. This is drastically different than the traditional pipe and stone system, where the soils are actually doing the filtering and treatment, explaining their large footprint. I encourage you to go to our website for more information on our product testing. This is an illustrated cross-section of the Advanced Enviroseptic pipe during normal operation. You'll notice the pipe is black and has many ridges and valleys to increase its surface area. It has been intentionally designed this way, knowing that the large surface area would be a host to the bacteria that break down the suspended solids. The pipe weighs approximately 18 pounds per 10-foot length and is approximately 12 inches in diameter with all its fabric layers. The pipe is mechanically strong enough to be used under parking lots, although it may not be approved for this use in your state. Let's continue. As warm effluent enters the pipe, it begins the treatment process. Skimmers, which protrude into the pipe, capture and retain solids, keeping them from exiting the pipe and clogging the outer layers. The first layer, what we call the bioaccelerator fabric, surrounds the pipe from the 4 to 8 o'clock position and screens additional solids from the effluent, enhances and accelerates treatment, facilitates quick startup after periods of non-use, provides additional surface area for bacterial growth, promotes even distribution, and further protects outer layers and the receiving surfaces so they remain permeable. The second layer, a mat of green coarse randomly oriented fibers, which separates more suspended solids from the effluent. This fiber layer acts as a coarse filter and adds to the surface area for bacteria to attach and digest suspended solids. Another very important purpose for the green fiber layer is that it serves to protect the outermost geotextile layer from coming in direct contact with the pipe. The pipe ridges also allow the effluent to flow uninterrupted around the circumference of the pipe. Effluent then passes into a final geotextile layer where it grows a protective bacterial surface, or what is known as the biomat, which is where the effluent is clarified to a very high degree. After passing through the biomat, the coarse system sand surrounding the pipe wicks liquid from the geotextile fabrics and enables air to transfer to the bacterial surfaces within the pipe, helping to maintain an aerobic environment, which is most efficient at creating a thriving ecosystem for bacteria to digest wastewater. Now let me introduce you to the components that you will use in the design and construction of your AES treatment systems. You've already seen the AES pipe. A few more details of interest are that the pipe is made out of a polyethylene polymer and is often composed of as much as 25% recycled materials. The geotextile fabric that surrounds the pipe is sewn and is a convenient location to grab and move the pipe. The sewn seam must always be placed in the 12 o'clock position during construction. This will ensure the bioaccelerator fabric is located at the bottom. The pipe comes in 10-foot lengths, weighs approximately 18 pounds, and can be easily cut to any length. Pipe lengths are joined together using couplings. You'll notice the couplings have 4 ridges, which engage up to 2 corrugations on each length of pipe being joined. Resting under the coupling, you'll see an offset adapter. This is an end cap with a single hole that will accommodate a 4-inch diameter pipe. It's placed on the ends of all the AES rows. It's called an offset adapter because the hole is offset from the center. That hole must always be oriented at the 12 o'clock position after construction. The reason will become obvious later on in the presentation. Offset adapters easily install without any tools on the end of the pipe. With its locking tab, all you need to do is firmly push the adapter onto the end of the pipe. The integrated locking tabs will engage the pipe corrugations. Then you can easily spin the offset adapter to make sure that the hole is in the proper orientation. Effluent is piped into the AES rows using these holes. You'll also notice a double offset adapter, which is simply an offset adapter with two holes, hence the name double offset adapter. The hole at the bottom is piped to a drain sump and provides a means of draining the field. We call this a bottom drain and is typically used in commercial systems. It may not be approved for use in your jurisdiction. Check with technical support for more details. Other typical components are the distribution box, which is used to divide flow to various portions of the field, and flow equalizers. Whenever flow is divided, you must use a flow equalizer. This helps to compensate for a D-box as it moves out of level over time. For example, if two D-box outlets were being used, then two flow equalizers would be required on these outlets. Never place a flow equalizer on a D-box outlet that is being used for a vent stack. That brings us to the last component of the AES treatment system, what we call the system sand. System sand is the material in direct contact with the AES pipes. System sand must meet the requirements of ASTM C33, which is a nationally accepted specification for concrete sand. This sand serves as the means of wicking water away from the pipe and evenly distributing it to the subsoils. It also provides enough void space between the sand particles to allow oxygen to be distributed around the pipe, which helps to maintain the aerobic environment critical to the desired bacterial processes. One final note: because small amounts of silt and clay can have a dramatic influence on the sand's ability to function properly, it is limited to 3%. This is shown as the material passing the number 200 sieve. A simple experiment helps to illustrate how important a sand's particle size can have on its ability to pass water. All of these samples received the same amount of water. You can see that system sand allowed more water to pass in a given time than did the finer materials. If water is retained by the sand, it will inhibit the aerobic environment we want in and around the pipe. Remember that the effluent is treated within the AES pipe. The sand is used to evenly disperse that water back to the subsoil. Advanced enviroseptic treatment systems have passed the stringent requirements of NSF 40 Class 1 protocol. This helps to justify up to and sometimes more than a 50% reduction in treatment area sizes as compared with traditional pipe and stone fields. Your state-specific design manual will provide the necessary sizing for your area. Our smaller treatment system results in less overall cost to the consumer, while still offering an environmentally friendly system. AES offers unique bed configurations, which include the traditional level bed, in addition to sloping, curved, or a combination of them all. This can often mean the difference between placing a field on a difficult site versus the added expense of pumping to a remote location. Your estate may not be approved for all configurations. Consult your design and installation manual for more information. Let's have a look at these configurations in more detail. This is a dramatic illustration of the advantages of using a sloping field versus the traditional level bed. The diagram at the top represents a traditional field constructed in a level format, which is contrasted by an AES system laid parallel to the ground. The offset to the water table is the same for both systems, but the level traditional field will require additional fill and impact to the site that the AES system avoids. AES systems function in sloping configurations due to the nature of the bioaccelerator and geotextile fabrics, which are the home for the biomat. After the biomat becomes established, it will provide a slight resistance to the liquid passing through it, resulting in the wastewater being evenly distributed throughout the entire length of the pipe. Once the wastewater leaves the biomat, it continues to be dispersed by the wicking action of the system sand surrounding the AES pipes. AES pipe is easily handled by a single installer. It is also very flexible. A single 10-foot pipe can be bent up to 90 degrees with no adverse effects. This often allows the field to be disguised by existing features like beside a driveway, or allows existing obstacles to be avoided. This picture represents a field that incorporates both a sloping design and curve to match the existing terrain. If this had been a conventional pipe and stone field, it would have been considerably larger, very visible, and would have required the removal of the mature tree seen at the left of this picture. If I hadn't told you a septic system was placed in the middle of this lawn, you might not have known. The owner was very pleased with the outcome. That brings us to the end of Part 1. In this presentation, you were introduced to the typical components used in an AES system and the importance of the system sand surrounding all the AES pipes. We also discussed the many system advantages that reduce cost to the consumer without compromising the environment. The treatment capability, smaller footprint, diverse bed configurations, and the passive nature of the AES system combine to solve many challenges presented by difficult sites.